Okay, we're just going to finish up the last little bit here about nomenclature. Then you'll be more professionals on naming. Then we'll talk about the study assignment when everything's due. Then we'll go start 4th of July early, I suppose, right? Like good stuff. All right. So obviously we've been talking about different types of naming. We pretty much, for up to this point, kind of really talked about ionic naming, type 1, type 2. And remember, whenever a metal is involved, that is the most important thing. And either you will or will not use a Roman numeral depending on sort of its location on the periodic table. We also saw that pretty much metals get involved with our polyatomic ions most of the time. So again, we fall back to those rules. And we just finished talking about naming acids, which really does revolve around whether or not there's oxygen or no oxygen involved. Once again, if there is no oxygen, that is the one that should have the hydro in the beginning. If there is oxygen, there should be no hydro, but it should end in, again, ic or ous, depending on how your polyatomic ion ends. So, if your polyatomic ion ends in 8, it should be ic. You can remember it like I ate too much, I feel icky, right? That's a good way to remember it. And if it ends in ite, it's going to be ous. Again, it's the hydro for a lot of people that gets them in trouble. They want to put it on everything for acids, to make it sound better. But again, make sure you don't do that. So the last sort of type of naming, for the most part, that we're going to talk about here is what's sometimes considered type 3 compounds. Type 3 compounds are basically nonmetals. So these are guys that are really sharing electrons. And these are really the easiest ones to sort of name and do. Although people do want to screw them up a lot by doing all kinds of things they shouldn't. So the nice thing here is you really don't have to do any type of figuring out charges. You don't have to do any type of balancing of anything. This is actually the appropriate place to use prefixes where people want to use them in all other places. This is the type of naming that you should use prefixes. And as we'll see a list here in a second, but like mono is 1. Di is 2. I think there's a table coming up. Tri is 3. Tetra is 4. Penta is 5. Hexa is 6. Hepta is 7. Octa is 8. Nona is 9. And a little deca action there is 10. So this is where we use these. Frankly, all you have to do is figure out how many you have of each element and basically use the appropriate prefix. So let's talk about that. When we're doing these type of naming, it is the first element in the formula that comes first in the naming part of it. And you do use the whole name of it. So whatever element is first in that formula, you use the whole name. You do use the appropriate prefix if necessary. The second element is named with the IDE at the end of it. So the second guy gets the IDE sort of ending like we do with our negative guys. And you also use the appropriate prefix. So basically, we use the appropriate prefix if necessary and the whole name of the first element. And we use an appropriate prefix. And the second guy gets the non-metal name with the IDE at the end of it for the second guy. Now, there are a couple rules and a couple things that we do in this type of naming that you do want to watch out for. The really main one, or one of the main ones, is we never use mono on the first name, but we can use it on the second name. So the second name, it's all good to use mono, but you cannot use it on the first name. The other thing that commonly happens is we sometimes get a couple of vowels that back up to each other, one from the prefix, one from the first letter of the element. So for example, if we had something like CO, this is carbon, which is a nonmetal. This is oxygen, which is a nonmetal. And at that point, all you should worry about is using these rules. We have one carbon, but we do not use mono on the first name. So we're simply going to use the whole name here of the first element, which would be carbon. The second one, we do have one oxygen, so we can use mono on the second name. So if we just write it with the prefix mono, and then the second guy gets the oxide. And this is what I'm talking about here with our prefix and our first letter. In this case, we actually get a couple of O's that sort of back up to each other. So we don't really call this carbon monoxide, right? We call it carbon monoxide, right? And so what we typically do is we drop off the vowel from the prefix. So this then becomes carbon monoxide in this case. So very common if you get like a couple of O's to back up from the prefix to the first letter, drop the O. You get like a and an O, you drop the A. Two I's are okay actually, but so those are the two sort of considerations that you want to watch out for. Some of those weird sort of naming with those guys. But again, there's nothing to balance here, nothing to figure out charges when we're doing nonmetals. Nonmetals is simply just count and use the appropriate prefix and just put the IDE on that second guy. Any questions on that there? So here's, again, the list of prefixes. And as I mentioned before, again, drop the A or the O if it sort of backs up to somebody that also has those kind of guys. And here's just a couple of examples of those. Now, tetraoxide, so we would drop the A there out of the tetra part of it, and it just becomes tetraoxide instead of monoxide. Obviously, again, we drop the O there, and it becomes monoxide. Now, there are certain things that just go by common names regardless. So H2O is an example of that. H2O is water. It is not a trick question. You see H2O, please write water. Do not write, dihydrogen monoxide, because nobody wants a refreshing glass of dihydrogen monoxide. It does not sound very good. NH3 is ammonia, so that also is a common name. That guy should not be confused with the guy we just saw a second ago, which is NH4 plus, which is a polyatomic ion, which is the ammonium ion. So those two guys get confused a lot. So ammonia, A at the end, no charge, NH3, it's actually a weak base. NH4 plus is the ammonium ion, and that is a polyatomic ion. So don't get those two confused. Another one you can add to your list is CH4. That is the simplest organic molecule you could have. That is known as methane. So these guys that are sort of common names, you should always kind of use the common names for them and not any type of other name. Any questions on that there? All right, so let's take a look at some here. All right, so for each of those, give the name, and let me give you some names, and you can do some formulas. Let's do dinitrogen pentoxide. Let's do carbon tetrachloride. Let's do some dioxygen tribromide. Could be making these names up. I probably am. All right, so names on the left there, formulas on the right. Okay, let's take a look. So when we look at this, we have I2O7, I is iodine, and O is oxygen. They're both nonmetals. So once you see that, you should be really happy because there's really nothing to figure out in terms of charges or balancing. You pretty much just need to pick the right prefix and write what's there. So there are two iodines, so the prefix for two is di, and we do use the whole name here on the first guy, so that would be diiodine. The two I's are okay in this case, oddly, it's okay. This is oxygen, and there's 7, so the prefix for 7 is hepta. And obviously the oxygen now will get the IDE at the end of it. So this is going to be heptoxide. Here we are going to drop the A off of the prefix, so we don't get the A and the O that backs up. Any questions on that one there? Coming over here, we got C and O, carbon nonmetal, oxygen nonmetal. So once again, a type 3 compound. We only have one carbon, so we do not use mono on the first name. So we will just roll with the whole name, which would be carbon. Here we do have 2 of the oxygens, which the prefix is di. And this would be carbon dioxide here, given the IDE there to our second guy. Any questions on that one there? Lastly, here on the left, we got phosphorus, which is a nonmetal. We got chlorine, which is a nonmetal. So once again, we only have one phosphorus. So whole name there, phosphorus. And we do have 3 of the chlorines. So that's going to be tri, and the chlorine gets the IDE at the end of it. So phosphorus trichloride. Any questions on any of those names there, how we got them? Probably the easiest of everything that you do would be what we do in here on the right-hand side. So as soon as I start reading, I see prefixes like di and penta. I know it's type 3, and frankly, I just write what it says. So di is 2, and nitrogen is N, so you write N2. Penta is 5, and oxide is oxygen, so O5. Again, nothing that needs to be balanced or figured out. Just going to simply write what is present. Coming here, I got carbon, no prefix, but I do see a prefix on the other side, and I know prefixes pretty much are only for type 3 guys. So because there's no prefix on the first one, I know there's just one of the carbons, so that is just carbon. Tetra is the prefix for 4, and that is chlorine, so that would be Cl4 there, CCl4. Any questions on that one there? Lastly, here we have dioxygen tribromide. So di is 2, oxygen is O, so that's an O2. Tri is 3, bromide is Br, so that is O2, Br3 in our made-up example there. Any questions on type 3? They're pretty straightforward. Again, they are like the easiest, I think, but they are really where people kind of screw up the most, you know, because they try to do all kinds of weird things. So once again, you should not be doing any type of Roman numerals with prefixes in this situation either. It is definitely wrong. Really, the only place outside of here in type 3 that you would have a prefix is like a polyatomic ion that actually just has a prefix in its name, like, you know, as I lost it there, there's like dihydrogen sulfate or something like that. So, you know, there may be a polyatomic ion that has a prefix as part of the name, but other than that, really, this is the only place where you should see prefixes. Any questions on type 3? Okay, then the last type of name we're going to talk about is sort of like the experiment we did the other day, and that's hydrates. And if you remember, hydrates, you know, have that kind of unusual formula of like MgSO4, and then there's a dot, say 7H2O. And as we talked about when we were doing these that experiment, this entire thing is the formula of the hydrate. And they do use that little dot to basically tell you how many waters have crystallized with that solid when it goes into sort of the solid state. So when we do this, as we talked about, there is a salt part and there really is a water part to a hydrate. And the water part is always named as hydrate. So the water part of it always gets the name hydrate. The salt part is pretty much named like a type 1 or type 2 compound. So in this case, we would look at just this part of it, and we would see magnesium, which is group 2, has a fixed charge. So it's a type 1 compound, and we would call this magnesium. And we would use the whole name of the polyatomic ion, which is sulfate. And we would include the water here as hydrate, and we would use a prefix to indicate the number. So 7, just like we just saw with the prefixes, there is hepta. So this would be heptahydrate for the water. Just like if we had something like once again, in our salt part, we would really just name it like normal. So we have iron here. That's a transition metal in a type 2. To figure out the charge on it, we do have 3 of the nitrates here, which obviously gives us a -3 overall. That means our iron here is +3. So like normal, this would be iron, Roman numeral 3, nitrate. And once again, the water part here would be named as a hydrate. So this would be pentahydrate. So hydrate's not too bad. Pretty much the salt part is an ionic compound. So type 1, type 2 naming. And then you just add the appropriate prefix for how many waters are present. And you put hydrate for water. So obviously if we had something like calcium or Ca, calcium sulfate trihydrate, and we want to write the formula, we would pretty much do it in the same two parts. We would start with the salt part, which would be calcium, which is a +2 charge. Our sulfate, which is a -2 charge, would give us CaSO4. And once again here, we would use our dot to indicate how many waters, which in this case would be 3. And we would do 3H2O because that is what hydrate would be. So if you had to go backwards, you would do it pretty much the same way. Any questions on naming hydrates? Any questions on naming altogether? Anything that we talked about?